Thanks very much, Lynn.
Okay, so what we're going to talk about today is just a slight modification of energy and environmental markets. But the idea is, it seems like where we're headed in terms of climate policy is into, if you like, sort of regional carbon markets or regional climate policy. These are just a list of some of the countries that are contemplating or at least have implemented carbon markets to essentially put caps on greenhouse gases or price greenhouse gases, which is essentially what the purpose is of a cap and trade program. Stable, predictable price into the distant future. So one of the big things that we were concerned about in California, the other thing I didn't mention here, is I'm a member of the Emissions Market Advisory Committee, which is a committee appointed by the California Air Resources Board of three pointy-headed academics to essentially look at how the market performs and make sure that essentially California doesn't become the lesson for what not to do and rather becomes the lesson for what to do. So one of the big things we were interested in is just what is going to happen to the price of allowances. And in particular, we wanted to make sure that there were adequate safeguards in place to essentially prevent unacceptably high prices, as well as what we see in the EU ETS at the moment, which is basically allowance prices virtually close to zero. So if you would like to mitigate your annual carbon, if you don't fly too much, it'll probably cost you about $50. So essentially, clearly, if you think through that certainly isn't going to do it in terms of the cost of dealing with carbon emissions. And so the other is this idea of just simply the fact that a big complaint of cap and trade markets that you hear often from the environmental community is that, oh, you're turning over the management of the environment to those Wall Street traders, and you know what Wall Street does, and there is truth to that concern, and so one of the things is really to try to understand that. So this is based on some work we did for this report, and the idea is that what we're going to do is try to forecast the future, what we'll call business as usual greenhouse gas emissions. And then from that, we know how many permits are issued over the entire 8-year period of the program. And so we can think of it as if you take total business as usual emissions minus the total amount of allowances, then that is essentially the shortfall between those two is essentially it has to be served by mitigation, meaning by people taking costly or not so costly actions to reduce their greenhouse gas emissions. And so the intersection, if you like, of that demand for allowances or demand for mitigation with the supply curve for mitigation is going to set the price of carbon allowances. And the big thing that we want to emphasize is there's certainly a considerable amount of uncertainty with business as usual emissions. The economy heats up, we'd expect likely a lot more carbon emissions. Other sorts of things, say the price of oil goes extremely high, that's likely to reduce emissions. So what we're going to do is, as I said, is the big thing is rather than get prices per se, what we're going to do is essentially look at the probability that we have essentially prices at the floor, because California runs a market where there's a floor on the price of carbon, currently about $10.50, and there are various what are called price ceilings, or is a price containment reserve that essentially says if the price gets above this level, the state stands ready to sell additional allowances, not a finite amount of additional allowances. So this is the price containment reserve. There's various price steps within the price containment reserve, and then you can exhaust the price containment reserve. And one of the big things that we were concerned about is if you exhaust the price containment reserve, the way the program is designed in California is you could get some really, really high prices, and typically likely politically unpopular and politically untenable prices. So what we're doing is looking at essentially this over the 8 years of the program, largely because allowances are bankable, which means if I have an allowance and I don't use it this year, I can use it next year. All right, and so what really matters is you would expect people to essentially intertemporal arbitrage. So the only thing that really matters is the time value of money, and at this point the time value of money is pretty low. So for the most part, we're simply just going to look at, it's for simplicity, look at this 8-year program. So a big challenge with California's greenhouse gas programs is that it was written by politicians And what does that mean? Well, it means that what they did is they designed a program that essentially said, for all electricity delivered and consumed to California, you must mitigate the greenhouse gas emissions associated with that. Now, that's a noble goal, but the trouble is that, you know, no one's ever seen an electron, nor have they seen the color of the electron. And so that really makes it quite challenging, because the one thing is that California is highly dependent upon electricity imports. And so, so one of the big challenges is, how do you essentially measure the carbon content of imports? The good news is we have lawyers. Lawyers define the undefinable for us. And in this case, as you'll see, it became a challenge that was too challenging. But the other thing is that the other thing that most of the programs, California is not alone, is that it has essentially a mechanism where permits are allocated. So what happens is that you get a allocation as a emitter of CO2 covered by the program that depends upon what your emissions were in the previous year. And what this does is essentially significantly steepens up your willingness to engage in mitigation. Why? Because if I emit 1 more ton this year, right, I get essentially, say, 0.9, if X is 0.9, I get 0.9 next year, which means the effective cost to me of an allowance is basically 0.1 times the current price of the allowance, because basically I get one for free, right, in the allocation if I do, which means I have much less likely of an incentive to take action to mitigate. But you can also see the other side of the coin, which is the fact that it certainly makes people more interested in participating in the program when you give them a free allocation of valuable permits, and you say that you're going to be able to keep that free allocation of valuable permits at least a fraction. So, you know, sometimes political expediency collides with what would be best in the terms of mitigating carbon. So this is essentially just a description of what the supply curve of mitigation or abatement looks like. So what we have are, the state has a number of measures in place that are supposed to be limiting carbon emissions, things like the low carbon fuel standard, other sorts of issues in terms of energy efficiency. Then there's this thing we'll call reshuffling, which we're going to briefly talk about, and that has to do with how do you handle electricity imports. And then this steep portion is really the fact of mitigation, if you like, at the margin in response to prices. And then up here, this is the price containment reserve. That's the length of the price containment, and there's 3 steps in the price containment reserve. And once you blow through that, you have no more, if you like, allowances left over to supply. So what is the sort of the issue with reshuffling? Well, it's the fact that California gets roughly 25% and even higher in many years of its electricity from the rest of the West. And essentially the way the physics of electricity works is, you know, electricity basically flows according to the path of least resistance. And so what will happen is the best way to think about it, as I said here, is like a bathtub. If there's more injected outside California than is injected inside California relative to demand, then power flows into California. And think of it as just like if you said, well, what water, is it the brown water or the green water that's flowing to California? If there's water outside California, if you like, it's sort of a mixture of the water. All right, and California lives within what's called the Western Electricity Coordinating Council, and essentially power injected anywhere here is essentially has an opportunity to, to come to California. Okay, so what do? Well, we sort of, the way we measured the carbon content of imports historically is we essentially defined it in terms of contractual terms. We said, well, if you have a contract with that generation owner to inject electricity, and if what happens is if he injects the amount that he said he would inject under his contract, and you consume at least the amount that you said was he injected under the contract, then we're going to deem that you've delivered the electricity. But again, that's just a pure legal fiction to the extent to which you've actually done that. And so the trouble is what can happen is that if you create a set of circumstance that says that, look, that brown stuff that's coming in, you've got to buy an allowance to essentially account for the greenhouse gas emissions associated with that. But that green stuff that you bring in, you don't have to buy an allowance for that. What do you think the suppliers are going to do? Well, what they're going to do is they're going to recontract. They're going to sell the brown contracts, and they're going to buy the green contracts. And the other thing that's true is, remember that California lives within the West, and if you like, the total supply in the West is typically many times during the summer necessary to meet total demand in the West. So what are you going to do? You're going to get basically California looking like it's essentially green, but West-wide greenhouse gas emissions are virtually the same. And that's what we mean by essentially reshuffling. So, so what happens? So pictorially, the simple way to think about it is just suppose that California's historically bought suppose California's roughly about a third of the West demand, and suppose historically California was buying essentially 250 brown, 250 green, and what was happening is that the rest of the West had this supply here, and this was essentially how California was sourcing it, with brown from California, brown from rest of West. What happens is California is just simply going to say, okay, what used to be brown coming in from the west of the West, we're going to now bring in green from the west of the West, and that is going to essentially get us under the cap. But what's going to happen is the brown, same amount of brown is going to operate, the same amount of green is going to operate. It's just that California pays more for green, and so that is essentially the problem. So this basically was a problem that was identified back in 2006, and essentially all sorts of machinations were effectively performed. And the bottom line is as we state, as I say right here, is essentially, unless you can violate the Interstate Commerce Clause, there's not much that you can do as a California to impact how generation unit owners outside of California operate their generation units. And so what this means is essentially reshuffling is going to occur, and there's not a whole heck of a lot you can do about it. All right, and so what effectively finally happened was, even though initially the Air Resources Board came up with a sort of attestation that they required, similar to Sarbanes-Oxley, where essentially all the CEOs of all the companies would have to certify that they had not reshuffled in serving their California needs. And as you might imagine, this caused all the CEOs quite a bit of heartburn. And so what happened is that essentially California ARB issued what was called a safe harbor for a whole bunch of actions, all of which looked a whole lot like reshuffling, that were essentially say that you wouldn't be in trouble for reshuffling if you did. So essentially, that allowed the program to move forward effective January 1, 2013. So essentially, that's what one of the big uncertainties is sort of how much of this is going to occur in terms of the supply of mitigation. So what we did is essentially think of it as quite simple. We just said, all right, think of this green line as sort of the distribution of business as usual emissions minus the total amount of allowances available, obviously except for the allowances in the containment reserve. And what we do is essentially just intersect that realizations from that distribution with the offer curve. So the simple way to think about it is that any realization of the difference between business as usual and total allowances that intersects in here is essentially we're at the reserve price floor. We're at the price floor, right? Then the next step is anything that is essentially above here means we're into the price containment reserve all the way up to here. And then here is essentially realizations where we blow through the price containment reserve. Now, the first thing you might think of is, gee, if I'm looking at the distribution of prices, the typical way we sort of think about it is there's some sort of mass in the middle, right? And essentially then there's a little bit of mass out in the tails. Well, in fact, as you'll see, it sort of is the opposite, because this right here is the probability that we get any price between the price floor and the price ceiling, okay? And it's because of how most of these programs get designed that you get a very, very, if you like, steep supply curve of mitigation at the margin. Think back to the output-based updating for industrials. Another thing that California did that a number of the programs do as well is they said you got to refund the auction revenues that you sell the auction permits to the electricity generators for, so they factor that in to what they offer their electricity at. You got to essentially take those revenues and essentially offset the price increase in the price of electricity so that consumers don't face that higher price. So another thing which essentially says, well, consumers are going to be much less interested in reducing their electricity carbon content of electricity because of the fact that they're being shielded by the increased price due to the carbon content of electricity. So essentially, the red dot is sort of more what the distribution looks like. And then here, I'll just, in the interest of time, skip over sort of what we did, but the basic idea is, think of it as, at the end of the day, what we get is a statistical model that effectively gives us the conditional distribution of emissions in each of these future years, all right, conditional on the information that we know up to this period. So one of the big problems is that for us is that all the greenhouse gas emissions inventory that the state has collected has only been known until very recently, up to 2010. So the only thing we knew was essentially gross state product, as well as some other variables, but we have to essentially forecast 2011, 2012, and then 2013 is the first year of the program, 14, 15, all the way up to 2020. And so what we have is essentially a distribution of business as usual emissions that is based on the uncertainty that we have, both in the fact that the statistical model that we specified, or think of it, for those of you taking statistics, in terms of the parameter uncertainty in that model, as well as the uncertainty in terms of future realizations of the shocks to that model, okay? So we're accounting for all those sources of uncertainty. And this is essentially what you get. So what we have here is effectively the blue line is the point estimate of the cumulative greenhouse gas emissions. And the reason there's a kink at this point right here is that the California program has two phases. Phase one is from 2013 to 2014, and it just simply covers electricity and large industrial processes. In 2015 all the way to 2020, it expands to include essentially natural gas consumed at your house, transportation fuels, meaning you're going to pay for the fact that there's greenhouse gases in the transportation fuels that you consume. And so that's why, this, as you can see, the sort of slope kicks up because coverage increases. And then the dotted lines are effectively point-wise confidence intervals, upper and lower 95% confidence intervals for the numbers. The other thing that we did is, if you notice it says intensities capped, is we essentially said, look, you got various, the way we specified our model was in terms of the intensity of the greenhouse gas producing activity. So for example, we specified one of the variables as greenhouse gases per vehicle miles traveled. We specified another as greenhouse gases per kilowatt hour of electricity produced in the state, with the idea being that, you know, these complementary policies are pushing that intensity to be less and less intensive in greenhouse gases. And so what we did is say, in producing these forecasts, we're going to forecast forward, capping intensities. In this case, we capped it at the sample median. You can see that in another case, we capped it at the 75th. And then the next we capped at the maximum. And as you, the only thing you can see is the point estimate doesn't change much, but the width of the confidence intervals gets bigger and bigger, as you would expect. Okay, so then what we do is we say, okay, we're going to run a whole bunch of different scenarios for that, what that curve looks like that I showed you, that supply curve of mitigation. And, you know, think of the complementary measures, that's what we're getting down here, at or below the offer floor. We have essentially low price responses. We have price responsive responses from gasoline, natural gas, and electricity. As we said, those are unlikely to be very big, particularly for natural gas and electricity, because of how the program is designed to shield customers from those price increases. And the good news, at least, is gasoline, it looks like that'll get passed through. But just to give you an idea, roughly $10 a ton translates to about 10 to 15 cents a gallon in gasoline, which is pretty much, you're probably not going to notice it. Okay. So what do? This is essentially the sort of, if you like, the graph. Every presentation has the graph, and this is it. And so what you can see is this is essentially the probability that we're going to end up at the floor. Okay, that will just throughout the entire program will be in a state of, if you like, excess supply. the sort of bizarre kind of purple color, that's the probability we're into the price containment reserve. And then the next one, that yellow one, appropriately drawn in yellow, that's the probability that we blow through the price containment reserve. Okay? And so that's the big concern, because if we blow through the price containment reserve, there's sort of almost no limit to how high those prices can get, and that's not a good thing. Now, the interesting thing is that little green sliver, the little green sliver is essentially this right here, the probability that we have any price between the floor and the ceiling on the allowances. So for the most part, you know, I guess just to finish on this point is to say, this is not necessarily a terrible thing, but the useful thing is to essentially set expectations of market participants. All right, and you know that the idea is markets function best when they have information available. Putting out essentially what this looks like is certainly going to hopefully help to limit price volatility, limit the incentive for those Wall Street guys to try to do the certain things. So, but still, the concern for us is essentially that yellow area. That essentially, is that something that is that a gamble that you really want to take? And you know, so the idea is just to finish up, is that one of the big things that we're at the moment pushing quite hard on is this idea that California needs to have a firm commitment to a maximum price. In particular, borrow from the future 2020 period to effectively defend that $50 maximum allowance price. The other thing that's interesting is that we've actually done this for the case of the EU ETS and said, look, if the EU ETS had done what we think that they should have done in terms of a sort of, if you like, stress test right at the start, what would they have found? And the interesting thing is this is essentially doing it for EU ETS, and you can see that for the most part, the green line is the actual emissions. So the fact that they're at the floor is no surprise, and would have been no surprise because this is the forecast for emissions up through 2012 that essentially we did from forecasting back up from 2000, I guess it was, yeah, 2006 forward. Okay, so the other thing is just to give a plug for Mark's talk. Mark is the Associate Director of PEZ, and he'll be talking next week sort of about some other stuff later this week, some other stuff we're doing in terms of trying to really stress test the California market, and then also a plug for the course we teach, and I'll stop right there. Question? Yeah.
The debate between a carbon tax and a cap and trade system.
Speak up.
It seems like the advantage of the carbon tax is it's simpler. Why create a complicated cap and trade system if there's such a small probability of being between your price floor and your price max?
It has very little to do with economics and mostly has to do with politics. Because think of a carbon tax as taking out the gun right now, pointing it at my foot and shooting it. Whereas the cap and trade is essentially taking out the gun, putting it in my pocket, and waiting a while before I shoot myself in the foot, and hopefully I'm out of office before that actually happens. I mean, that's largely what it is. Is it really? Because a tax is basically you pay it now, and you know, and you can. There's just no way around it. Whereas this, I can give you the allowances, and you'll be like, yeah, oh gosh, I love this cap and trade program. That's free money. With the tax, what can I do? I can say pay. And you just think of it as everybody hates that, right? Whereas with cap and trade, I can give you some money, I can give him some money, and there I go. And if at the end of the day, you know, what I'd expect to happen is that pretty soon people will figure that one out. But first we got to get these programs in place, and then people can go, hey, wait a minute, we're just giving money to all these firms that, you know, with these allocations, let's allocate less, let's scale it down. Then you can transition to a tax. It's sort of, you know, camel's nose under the tent problem, I'd say. Anybody else? Yeah.
So it seemed to me that a big reason for why there's a high probability of the price being at the floor in California is because of this reshuffling issue.
That's part of it, yeah.
So in the EU example, is carbon leakage also a factor in why the price at the floor? Are there other?
I'd say there the big issue is a lot of what's going on there is having to do with offsets, and which is something we haven't really talked about. But the other is just simply the fact that you know, there's a high degree of correlation between greenhouse gas emissions and the level of economic activity. That's one of them. The other is that for those of you who are sort of green energy enthusiasts, you probably all know what's going on in places like Germany, Spain, and the like. They're basically going bankrupt, you know, putting large sums of money into, you know, wind, solar, which don't produce greenhouse gas emissions. So, you know, that is, you could sort of say they're solving the problem. And so, you know, one measure of their success is the price of the EU ETS allowance. But, you know, you sort of, trading those two things off, it sort of, what one would hope, right, is that price signal would provide the incentive to invest in the green technology rather than, you know, we're going to, you know, try to subsidize it and to drive that price down. So think of it as sort of two wrongs in some sense making a right, in that we're reducing carbon, but it's pretty darn expensive for these countries as they're learning. Yeah.
Am I right in saying there was one slide that you showed that actually had the greenhouse gas emissions reductions, I think, and I thought it said that the reshuffling was basically the biggest reduction there was?
Yeah, I mean, it's first off, it's not a reduction. I mean, just the important thing to think about is the following: is that California has reduction to 1990 levels is essentially a week in China. So, you know, the idea here is that what we're attempting to do is demonstrate that you can actually put in place a cap and trade market. You can set a positive price of carbon. You could potentially get investments that wouldn't have taken place but for that. Worrying about the fact that you're reducing greenhouse gas emissions, you know, I mean, we got to get the rest of the world on board. We got to get China on board. I mean, if we're really going to do something about it. So, you know, I would just say I wouldn't worry about the fact that you know, trying to effectively measure the reduction in greenhouse gas emissions as a result of the program, simply because California lives within the West. The West greenhouse gas emissions, it's an extremely difficult task to actually measure it.
Are there any plans to expand it first to the West and then to the U.S. as a whole? Or?
Well, put it this way. It started out as the Western Climate Initiative in 2006. Guess what happened in 2008? And guess what happened as a result of that, what happened in 2008? Everybody bailed but California. So we basically got to get everybody back on the table. And I can see Lynn getting a little antsy, so I should probably stop.
Great. Thank you very much.